So, how's everybody doing out there? Well, welcome to day 10 of Corona Online School. So, hopefully, everybody did a good job with the addition and subtraction models or algorithms. So, today we want to move into multiplication and division algorithms. And so, again, we're just trying to focus on multiple ways that we can teach students how to do multiplication and division. So again, I want you to get the right answer, of course, but again, we're focused more on learning the model and being able to actually demonstrate how to use it and stuff like that. So in this case, if we look at multiplication, we've got 5 that we're going to be looking at. And so some of them look similar to maybe what we saw before. And they are a little bit similar because if you think about multiplication, it's just another way to think about repeated addition. So some of these models that we're going to be doing are going to be repeated addition models. So let's jump right in and look at example 1 here. And so example 1a, we're going to use the base 10 blocks, and it says find the solution of 6 times 3 by using one of the following algorithms. So in this case, what we're going to do is we're going to use our base 10 blocks and kind of repeated addition in this case. If we're multiplying 6 times 3, so what we're going to do is get like 3 dots, and then we're going to write it six times. 1, 2, 3, 4, 5. And so again, like what we know we've got is 18 dots. But again, what we want to do is just like when we were doing addition and subtraction, if we've got more than 10 of any one, we want to regroup them and turn them into, like in this case, a strip in this case. So I'm going to go up and circle 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here's 10 of these guys. So I'm going to take that and turn it into a single strip, and that gets rid of those. And then let me just verify that I don't have another 10 laying around. So 1, 2, 3, 4, 5, 6, 7, 8. So that's perfect. So in this case, my final answer would be 1 strip and 8 dots, or 18 in this case. And obviously by looking, we know 6 times 3 equals 18, so we're good to go. So again, so that's how we're using the base 10 blocks in repeated addition to solve this problem. So place value cards, we're going to do kind of the same thing. So the idea is we're going to take 6 times 3. And so again, we're going to just go ahead and do six rows of 3 dots each. And then again, just like we did over here, without having the columns, we want to cash in 10 of these ones positions and turn them into a single dot in the strips position. So that gives us that dot, and we got rid of those because of it. And so now bring down 3, 4, 5, the remaining dots. And then hopefully we see we've got 1 in the tens position, 8 in the ones position. So again, looks like we did it right. So we've got 18. So again, that's our using match strips and blocks and place value cards in addition to kind of repeated addition to make these guys work. So we really haven't done any multiplication for the most part. We really just kind of expanded these out and rewrote them as an addition problem so we could do it. All right, so let's look at example 2. So it's a little bit bigger example in this case. So in this case, we're multiplying 3 times 154. And so in this case, we're just using place value cards, expanded notation, and then final. So with place value cards, we want to do kind of the exact same thing above, except in this case, I'm going to repeat the 154 3 times. So let me first write 154 in terms of place value cards. So that's what 154 would look like, but since I want 3 of them, I'm going to do this 2 more times. And so now, just like above, I want to regroup any of these that are that are 10 or more. So that way I can kind of shift them over. So in this case, here I've got 10 in the ones position. So that means I can bring down a single dot in the tens position and then get rid of those 10. And at this point, I still have 4 left over. So let me just go ahead and bring these 4 down. So now let's do the same thing in the tens position. So again, I've got 2 rows of 5, so that makes me a 10. So let me put a little dot down here in the 100s position. So I've taken those 10 tens and turned them into a single 100. And that still leaves me 5 dots that I can bring down for the next row. And then finally, there's nothing to group in the 100, so I'm just going to bring those 3 down. And now, so we go through and total each of the different positions. So in the ones positions, I've got 4 dots. In the tens position, I've got 1, 2, 3, 4, 5, 6 dots. And in the 100s position, I've got 1, 2, 3, 4 dots. So it looks like my final answer would be 464 in this case. All right, is that everybody okay with place value cards? All right, perfect. So for expanded notation, what we're going to do is actually kind of write, in this case, the 3 that is kind of already in it is expanded form anyways. There's not much to do there. But we're going to take the 154, and instead of thinking of it as 154, we want to think of it as 100 times 50 times 4 in this case. Or if you wanted, you could think of it as 1 times, plus 5 times 10 plus 4. And then what we're going to do is we're going to rewrite this so that, depending on which form you're using, hold on, I should have pluses in here. What am I doing? There we go. And so what we're doing then is going to basically distribute this 3 to each piece on the inside. So we're looking at multiplying 3 times 100 plus 3 times 50 plus 3 times 4. So 3 times 100 gives us 300. 3 times 50 gives us 150. And then 3 times 4 gives us a 12. And then we just add those guys up from there. So 300 plus 150 is 450 plus 12. Equals 462. All right, hold on. So where did I mess up on the last problem? Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I see what I did on the last problem. So hopefully somebody would have caught this in class. Let me erase this. I wrote these in chunks of 4 instead of chunks of 5. That was silly. Hold on. Sorry. Let me rewrite these in chunks. Oh, I guess that's the way I was supposed to do them, in chunks of 4. I just didn't count very well, so in this case, I want this 4, and 2 of those, and that's what's going to turn into that 1 dot. So that just leaves me 2 left over. So 462. Good. All right. So hopefully somebody was screaming before I even moved on to part B there. But anyway, so that's expanded notation. And then final is just like what you would expect. 3 times 4 is 2. 3 times 5 is 15 plus 1 is 6. 3 times 1 is 3 plus 1 is 4. And so we get 462 in that case. All right. That okay with everybody? Perfect. All right. So let's look at example. Oh, what happened here?